fellow scientist and mathematician. Welcome to my YouTube channel, which focuses on mathematics and science. Welcome and let us learn together, whereby mathematics is simplified together with the physics from the fundamentals so that every person can learn and understand the rules step by step. My channel name is Luke Aaron 1. Welcome and let us learn together. Fellow scientists, I want us to consider now vertical, circular, uniform motion, whereby we are going to consider a ball which is moved in a vertical circular motion as shown in this figure. So the ball, as it revolves around the vertical motion, the tension will change. The tension or acting on the string will change at various points of the circle. So in our explanation, we are going to let r small r to be the radius of the circle, m is the mass of the ball, and v is the linear velocity, omega is the angular velocity, t is the tension on the string. Then we are going to consider point A, B, C, and D. Now at point B, we will begin with at point A. At this point here, the tension is acting towards the center and the weight is acting downwards. As we know, always the weight acts downwards. So at point A, the difference between the tension and the weight providing the centrifugal force, the resultant between this tension at point A and the weight is the one which will give us the centrifugal force. So TA, that is the tension at point A, minus weight will give us the centrifugal force, the force which makes the ball to keep on moving on a circular path. So we can rearrange this to get that TA is equal to mv squared over r plus mg. W is the weight, and so we can write it as T is equal to mv squared r plus mg, where this is the centrifugal force, mg is the weight of the body. Then at point B here, both the tension is acting downwards. The tension on the string is acting downwards, and the weight is acting downwards towards the center. So the sum of the tension and the weight provide our centrifugal force. So TB plus weight will give us mv squared over r, which you can rearrange. We can make TB the subject of the formula, and when we do that, we are going to find that TB is equal to mv squared over r minus mg. So that implies that that tells you that clearly from this equation here, this equation, TA is equal to mv squared over r plus mg, and the other one, TB, is equal to mv squared over r minus mg. That shows us that the tension at point A is maximum. It is greater than the tension at point B. So the tension is greatest at the bottom of the circle when an object is moving in a vertical circle. The tension is greatest at the lowest part, and it is smallest at the topmost part. Now, at point C and D here, the weight acts perpendicular to the centrifugal force, and also at point C, the weight is acting perpendicular to the tension. So the weight will not contribute to the centrifugal force at both at point C and D. At point C and D, the weight does not contribute to the centrifugal force because it is perpendicular to the centrifugal force. So tension on the string is the one which is going to provide centrifugal force at point D, and at point C. So when at point B, when weight is equal to centrifugal force, that is mg is equal to mv squared r, then at that point tension will be equal to 0, because if if centrifugal force is equal to weight, then these are equal, and they are going to we are going to get 0 from them when we simplify them. So the tension at point B will be equal to 0. Now from this one we can obtain the minimum speed for which the ball will remain in the circular path, and that minimum speed is given by square root of r times g. So this is the minimum speed, v minimum, that is the minimum speed at which the ball will remain in a circular path. In case the speed is less than that, then our ball is not going to stay straight on a circular path. So next time we are going to look at the sample, the numerical example on how we can apply this principle to get the maximum tension and the minimum tension when the ball is moved in a circular path. I have also provided a simulation of the ball moving around a vertical circular path after this discussion, so that you can view and see how this one comes about. So much for watching this study. Kindly like, subscribe, so that you won't miss any single video which I upload now and then. Also, you can make a comment there. You can suggest any area of study which you would want me to address, and I will be more than willing to tackle it on your behalf. Thanks so much for your support, guys.